Welcome to our video on compiler design. Today we're going to explore some fascinating concepts that form the backbone of software development. By the end of this video, you'll have a solid understanding of what compilers are and why they are crucial in programming. Have you ever wondered how your favorite programming languages convert your code into something a computer can understand? Imagine writing in English and having it transformed into a language that machines can execute. Let's dive into the fascinating world of compilers. A compiler is a special program that translates high-level programming languages like Java or Python into machine code that your computer's hardware can execute. Think of it as a translator that helps bridge the gap between human-readable code and machine language. Key roles of a compiler. Translation converts high-level code into machine code. Error checking identifies syntax and semantic errors during compilation. Optimization enhances code performance before execution. Compilers are crucial in software development for several reasons. They allow developers to write in high-level languages, which are easier to understand, while the computer executes instructions in machine language. Without compilers, programming would be cumbersome and error-prone. Real-world examples. Game development. Compilers convert complex game code into optimized machine code for better performance. Web applications. They enable languages like JavaScript and Ruby to run efficiently on servers and browsers. Let's differentiate between compilers, interpreters, and assemblers. A compiler translates the entire program at once and produces an executable file, for example, GCC. An interpreter translates code line by line, executing it on the fly. A common example is the Python interpreter. An assembler converts assembly language into machine code, like NASM. The compilation process involves several stages from source code to an executable file. Key phases include lexical analysis, which is breaking the code into tokens. Then, syntax analysis, where the token sequence is parsed for grammatical correctness. Next is semantic analysis, ensuring the code's logic is correct. After that, code generation translates the validated code into machine code. Finally, optimization improves performance and efficiency. Compilers are integral to many real-world applications. Notable examples include the GNU Compiler Collection, GCC, and Clang, which are widely used in software development. Compilers significantly impact software performance, enabling efficient execution and faster development cycles. Understanding compilers is essential for anyone in the tech field. They are the backbone of programming languages, making development efficient and effective. Don't forget to like and subscribe for more insights.